So we just discussed a case of interaction between light and matter, where the matter piece is very smooth, so the photons or the light waves hit the surface and bounce, and that's reflection, and they do it in a very nice way, very simple law, and so on. Another possibility is that the light might go through the material. It doesn't mean it's not interacting with the material, right? But it's just not bouncing, or at least part of it is going through the material. So if you have a transparent piece of whatever, it has atoms. Let's say that they're all, typically they won't be in this organized way, but let's just assume that they are. You get the light waves coming in, or your photons, and the photons get absorbed by the atoms, right? The atoms keep excited for a little bit. When they finally decay, they shoot out the photon with the same frequency that it absorbed. So the photon between the atoms travels at the speed of light. There's no question about it, because it's empty space between the atoms. So the photons move with the speed of light. But then when they hit the next layer of the material, those photons get absorbed. The atoms get excited for a little bit, or the molecules get excited for a little bit. So that puts a delay on this process, and then they finally shoot them back out. So the photons is like a relay race, right? Where there is a time delay between, grabbing the baton from the next person and starting to run. So each runner, at each segment, the light is moving at the speed of light, but the delay caused by the atoms slows down the overall propagation of light. So that implies that the speed of propagation in any transparent material is less than the speed of light, where n is bigger than 1. V is less than C. Okay? Now when you send a light and it hits the boundary between two materials, two transparent materials. So you send a light ray coming this way, and this is one material, and this is a different kind of material. Wave theory tells you that there will be a reflection of that wave just because you're changing the medium. So there is reflection, and the law of reflection tells you exactly how that reflection is going to be, in what direction it's going to go. But wave theory tells you that some of it is going to go through also. Part of that wave is going to go through. It might go through, if you keep looking at the rays of the wave coming in, it might go that way, or maybe they change direction, right? So they do change direction, and that's what I want to show you. So I have two transparent materials here. The top is just air. Here is probably a plastic or acrylic, and I have laser beams being shot, these three of them, at parallel to each other at a certain angle from the vertical. They hit the surface of the acrylic, and you see what we just said, that there's going to be a reflection, and this angle is going to be equal to that angle. But then part of the light ray, part of the incoming light ray goes inside the material. It's continuously being absorbed and emitted throughout as it moves through the material, but the overall trajectory changes. It was coming in this direction, right? Now it's moving in a different direction. That phenomenon is called refraction. And all that there is to it is the change in velocity of light, the difference in the velocity of light in the two mediums. I think the easiest way to picture that is with this. Suppose that this is grass, and you have a little toy that just has two wheels and an axle. Say this is cement. Smooth cement. So you send this little toy at an angle, and because it's coming at an angle, and the grass is going to slow down the motion of the little toy. The first wheel that makes contact with the grass slows down. While this wheel has slowed down and moving at with a different speed, this wheel is still moving with the original speed. So after both of the wheels have come into the grass, there is a pivoting that happened to the little toy, because the first wheel to touch ground has been delayed for a longer time than the second wheel that touched the grass. So that immediately tells you that the change in direction of the wheels is due to the difference in speed in the two mediums.